Well, bam. Hello, everyone. Good morning or afternoon, evening, wherever you are. We have a really exciting guest today. We have an actual Google employee on stream, and we're going to do some LeetCode problems together. Her name is Belle. Belle, can you introduce yourself, please?
Hello. My name is Belle. I'm very excited to be here. Can't wait to solve some liquid problems with you, Brian.
Yep, I'm excited too. Also, my name is Chet, by the way. Okay,
I thought your name
so
was Chad.
okay, so I'm gonna make a room over here. It's gonna generate like four random questions. We can select what problems we're comfortable with. Can you see my screen, by the way?
Yep, I can see your screen.
Okay. Um, okay, sure. Let me know what problem types you're okay with. Do backtracking. Holy crud. I know what binary search
We
is.
need to do DP hard questions.
DP hard questions. Dynamic programming. Bam.
No, chill, bro.
Game theory. Graph. Greedy. I know what those are. Hash function. I've never used the hash function heap in Python before, which is what we're going to be coding with today. I know what iterators are, linked list. I know how to do a little math, but I don't like it. Prefix sum, queues, recursion.
Love recursion.
I love recursion too. Do you know are you good with shell programming?
I shall every day at work.
Oh, every day at work. Oh yeah. What do you even, like, do you code with Python a lot at work or it's mostly shell?
Have you heard of brainfuck?
Brain funk?
Fuck.
Like this? Brain,
I think secret.
what'd you say?
It's the standard programming language for all programmers.
This? Brain F?
Yep. Oh, are you allowed to curse? I'm sorry.
Yeah, you are. Two pointers. Okay. Do these look okay to you?
Like straight.
Yeah?
Yeah, let's do it.
Okay. Easy, medium, hard. Oh my goodness. This is the first time we're doing a hard problem, by the way. I've turned on hard. I've never turned on hard for
It's
anything
my first
before.
time too.
Okay. Create room. Oh, how good are you with Python, by the way?
I'm alright.
I just started learning Python like
Not a pro.
this this month, I think, because my job uses it and I need to ramp up on it. I'm still really rusty on it though. Oh, hello,
This is great
Velveteen.
practice.
Hey, look, someone said hi in the chat. Hello. This
Hello.
is this is Belle. She is a actual Google engineer. Very, very qualified to be doing this.
Certified.
Mm. Okay, first problem. Number of lines to write string. Do you want to do some popcorn reading here? You are given a string S of
Yeah, let's do it.
lowercase English letters and an array widths denoting how many pixels wide each lowercase English letter is. I'm already so lost.
Since when do letters have pixel width.
String S of lowercase English letters and an array of widths denoting how many pixels wide each lowercase English letter is. But yeah,
You're
kind
trying
of
to
weird.
write this across several lines where each line is no longer than 100 pixels.
Starting at the beginning of S, write as many letters on the first line such that the total width does not exceed 100 pixels.
Then, from where you stopped in S, continue writing as many letters as you can on the second line.
Holy.
Continue this process
Continue this
written all
process
of
until you
S.
have written all of S.
Seems easy.
You want to read the rest?
Yeah. Return in a result of length 2, where result index 0 is the total number of lines, and result index 1 is the width of the last line in pixels.
Okay. Result 0 is the total number of lines. Result 1 is the width of the last line in pixels. So basically your remainder, huh? I'm so confused already. Let's look at an example. So we have a bunch of widths here. Everything is 10. Is this like all 26 letters of the alphabet? And an array widths denoting how many pixels by each lowercase letter. Okay, so I'm guessing this is like A to Z. Each one of them is 10
Still
long.
the same size.
For at least for this one. And then we have, okay, I think they want us to write A through Z. Output is 3, so 3 lines with 60 pixels left over, like on the last line. You can write S as follows, okay, 100 pixels wide, 100 pixels, 6 left on the end, 10. There are a total of 3 lines, and the last line is 60 pixels wide. Oh my goodness. Oh, Velveteen is typing in the chat. He says, you have to put as many characters in S as possible until the width of the line is 100 px, and then you go to a new line up. All right, that makes sense.
Thank you, Valentine.
Thank you, Velveteen. Okay, example 2. So everything is 10 except for 4, and then type BBCCDDAA. 2 lines, 4 remainder. Huh, okay. So 98 on this
It's
line.
interesting how the same character can have different widths. Right, like the first B is 4, but the second B is 10.
Wait, is that how it works? I thought this meant like A is 4.
No?
Every single A is 4 pixels wide.
Oh, you're right. Yeah.
Yeah, and then
I
B is
misunderstood.
10. I think that's how it works. I'm so confused.
Maybe let's start off with a naive algorithm so we can turn all the letters into an array of numbers.
Okay. Maybe we can start off like what will be a naive algorithm. So for every single letter in this string, we need to find out what its width is, and then we subtract it from 100. And then every time we get to a like negative number, like 100 gets subtracted to a negative number, maybe we restart the 100 count and then we add to a number of lines.
Love the idea, Chit.
Love the idea, Chet. I love the text and draw you have going on. I can't stop laughing at him when you start doing it.
Comes out. I'm sorry.
Okay, so what do we need to track? We need to track int. Let's do current line width is equal to 0. That's our current line width. We need to track how many lines we have. Lines is equal to 0. Okay, and then we need to iterate for every single letter in this string. So for, do you remember how to do a string iteration in Python?
Well, I believe all you need to do is no for A in this, and which will go through each character in the string.
For C in, is that what you're saying? For C in S?
S.
Oh, is that how it works? I can do a sanity check and print out C. Okay.
Yeah, not
Current.
true.
Okay. I'm not sure either. I've only started learning Python like this month, and I still really suck at it. Okay, sanity check time. Let's just print this out and return some bogus value. Run. Invalid syntax. Oh, there's no... You don't have to specify the data type in Python. Dang.
Oh, I thought that was something new. Well, what you can do is you can specify the type after you define the variables. You can do a
Yeah, you can
colon,
do
and then you can say
yeah, you can do something like that, right? I don't think anybody does that in LeetCoding coding though. It's like a waste of time. Okay.
you're just a man of high quality code.
Current char. What is going on here? Why is it UA? Huh.
I think we can ignore that. It's
You can ignore that?
probably.
Are you sure we can ignore
Yeah.
this?
Yeah, no. So yeah, if you what you can try is do sanity check and see if C equal, and you try normal string and see if that equals.
A normal string? Wait, I didn't get what you said. A normal string? Wait, hold on.
Actually, we just get to the part where we do the conversion to the actual number. So what you can do is you can do ORD, and you can find the order of the character. So ORD, the letter A is something like 60 or something like that.
Oh. Oh, wait, how do you figure out how do you map the character to a number?
Yeah, so the function is ORD.
ORD?
Yeah.
Oh, C? Oh. So,
And you can try printing it as part of the string above just so we can sanity check if you'd like.
yeah. Your text and draw, man, again. Current int. Okay. Okay, let's run this. Okay, yeah, let's screw the typing. Nobody does that in LeetCode. Okay. Whoa. 97, 98. Oh, they are in order, so we have to minus 97 from it, I guess.
Amazing. Yeah, so minus 97, like you mentioned.
Minus 97. I still count with your text and draw. Yeah, we got it. We got the index. Okay, I'm still so paranoid. What is with this US over here? Are you sure that's fine?
I'm kind of curious. Can you grade out on incognito?
Incognito? What about incognito?
On Google, I mean.
Oh, Google.
Can we Google
Let's
it?
see. Sure. Python. Why do my characters look like this when I print it? Or I can just do like Python, how to iterate over string for character in my string print character. Huh, that's exactly how we're doing it. Python print character in string. Why does my character
Yeah, I
have...
believe it's just the encoding of the character. So the U represents probably Unicode encoding.
Oh, you're right. U prefix distinguishes Unicode strings. Okay, so we're probably good. To get rid of it, you can convert the string to regular byte string using string before printing. Ah. There we go. Okay. I guess I'm just paranoid for no reason. Okay, so we get the current width of the
That we have
character.
some progress here.
Width is equal to what's the array called? Widths. Okay, is equal to widths square bracket I, and then current line width we can just add the current width, I guess, plus equals width. But if it goes over 100, then we have to make a new line. Maybe we can do like an if statement, like
So we can do that check before we add it.
we can do that before we add it.
Yeah.
Oh, do
so
the
we
if
do
statement check?
Something like, yeah, like if we call this current line with is over 100 or less than 100, then we add it.
Oh, yeah, you're right. Plus width is greater than 100, then you increment your line count. Line plus equals 1, and then you reset your, oh, you reset your current line width. Yeah, is equal to 0. And then you add your width to the current line width. Oh, that's nice. Okay. Okay. Maybe let's do another sanity check, like, let's do lines, comma, current line, and then current line width, and the current line width, like that. Sure. Oh, lines is equal to lines.
Oh, I think the problem is print only takes in. Oh, wow. Câu nói lại.
Okay. Okay. So at character A of 20, and then we reset at line L or K. Yeah, that seems about right. K. At current char is K. Index is 10. And we reset it to 10. Okay, I think we're on the right track. Yeah. Okay.
This is looking good.
This is looking good in the Texan way. Okay, and at the end, we return how many lines we have, right? And an array, we return in an array, so man, I love array literals in Python. You can just type this lines and then current line width. I think that's how it goes. Oh.
Come on, me and entities where should be.
Expected 3 and 60.
Yeah, maybe understand lines equals 1.
Oh. Yeah, you're right. We always start at line 1. So run. Let's go. Oh. Okay. Submit. Shia. Oh, let's go. Wait, let me get rid of all the print statements and submit. Surely it's gonna be faster. Oh, let's go. Yeah. Wow.
I never seen the solution that fast.
That fast. How long did that take? I have no idea how long that took. Maybe like 10 minutes. Wow, that was nice. Okay, are you ready for a medium problem? We have 2 to choose from. Maybe let's see what the problems are, and then we can decide, oh my goodness. Oh, two best non-overlapping events. This looks like a hassle already. Want to do some popcorn reading again? You are given
This
a
looks treacherous.
zero index 2D integer array of events where events I is equal to start time, end time, value. Oh my goodness.
Vậy thì start is start time and end is end time. And if you choose to attend this event, you will receive a value of value.
You can choose at most two non-overlapping events to attend such that the sum of their values is maximized. At most two. Okay.
Turn this maximum shell.
Note that the start time and end time is inclusive. That is, you cannot attend two events where one of them starts and the other ends at the same time. Oh.
More specifically, if the intended event was the mean time t, the next must start at or after t plus 1.
Okay. This looks like the type of problem I would fail at an actual interview. I've never been good at overlapping event stuff. So these are the events.
What's the second problem?
Yeah, majority element. Hey, I know how to count majority elements. Oh, given an integer array of size n, find all the elements that appear more than n over 3 times. Wait, this looks easy. I hope I'm not counting my chickens before they hatch, but it looks easy. I mean, okay, so we can figure out what size n is easily, just len of this entire thing. And then we can keep a hash map of, yeah, we can go from start to end and keep a hash map of all the counts of every letter, right? And then we can iterate through the hash map and then see which values are greater than, you know, length of this divided by 3, and then return those in an array.
Sounds good. Seems
Yeah.
like after we do that, we can figure out how to solve the problem in linear time in all of one space.
Oh wait, I didn't see
Seems
this.
like a real medium challenge here.
Could he solve the problem in linear time in O1 space? Huh, O1 space.
Their solution is already in linear time, but the space complexity seems a little bit higher.
Think about the possible number of elements that can appear more than n over 3 times in an array. The range of the numbers that could appear is really big. It can be at most 2. Why? Wait. Think about the possible number of elements that can appear more than n over 3 times in an array. It can be at most 2. Why? So only at most 2.
I see.
Oh, because... Wait. Huh. Wait, I don't get it.
Yeah, because if you have 2 elements that are at least 1/3, then now you have a little bit over 2/3. So now you can have a 3rd element. It's like the pigeonhole principle.
Oh, well, yeah, you're right. So but we have 3, and it's strictly more than n over 3 times. Oh, so if 2, if one takes like a little bit over a third, another takes over a little bit over a third, then there's no chance any other element can do that or can take up more than n over 3. Oh. Consider using Boyer-Moore voting algorithm. I do not know what that is. Is that pigeonhole again? Which is efficient for finding elements that appear more than a certain threshold. Oh. Wait. Huh. How do we take advantage of the fact that it can be at most 2? What if we just had...
I can think of...
Mm-hmm.
What if we had
Oh, I mean, I was just thinking out loud. What if we had just one variable counting the count of something? Oh, wait, just two variables? Yeah, I don't know. What was your idea?
Well, no, I haven't said the solution yet, but just working on a more naive solution. You could go through and do the hash map that you mentioned. And then from the
Oh,
hash map, maybe we can optimize the time complexity here.
okay. Sounds good. Sure. Let's make a hash map then to count off all the counts of every element. Um, how do you do a hash map in Python again? Is it dict? Um,
Yep, Nintendo two curly braces.
counts, oh, two curly braces. Thank you. Okay. And then for every single num in nums. And let's see, counts of num is equal to, how do you do, is there an equivalent of get or default in Python?
Yeah, there's a get. What are you trying to get?
Um, counts num plus one, but I want it to default to zero if num doesn't already exist. Is there like something like that in
I don't
Python?
want to be honest. I don't remember the.
I don't remember either. Python get or default, oh, here. Dict.get key, default value of, oh, it's here. Get or default to zero. That's convenient. I like that. Counts get num or zero. That's nice. Okay. And then for sanity check, we can print out what our count is at the end. Run for, oh wait, I was doing Java syntax again. Nums in num. Okay, cool, I think it works. 2 is mapped to 1, 3 is mapped to 2. Wow, this is so clean in Python. Huh. 1, 2. Okay.
What were you using before Python?
Well, actually, I don't think it's. Oh, I was using Java. On second thought, it might be similar in line count, actually. Java is like get or default, which is slightly longer. Um, and then in Java, you have to use a whole hash map class. You have to instantiate it first, and then do a dot put. But yeah, you can just do this instead of a whole class thing. Oh, you have to specify the types too. Like, oh, this has to be an int, and that has to be an int. And you can't even use int too. You have to use an integer for like objects, which is annoying. But yeah, I'm liking Python
Amazing.
so far. Yeah. Okay, we have the counts. How do I iterate through all the values or items?
So we can do this thing, or you do X4 and then sequence, and then you can do either the keys, or if you want, you could do both the keys and
Oh,
the
for key,
yeah. So you do
comma.
dot keys and you do dot items to iterate over both.
Oh, the items. Okay. For
Okay.
counts dot items. Oh, that's convenient. Okay, let me print out the keys. Uh, key, comma, value. Make sure I'm actually doing this right. Oh, bam. Oh, 2 to 1, 3 to 2. Okay, we good. Yeah. Okay. So let's make a array for our results. Results is equal to an empty array, and then we can do if the value is greater than n over 3. Let's do n over 3 over here, so we don't have to calculate it every time. So len of nums divided by 3. Okay. If val is greater than n over 3, then you add it into the results. Results. Is it append? Is that how it works in Python?
Yep.
Hey, nice. Key. And then in the end, you return results. Yay.
Amazing.
Amazing. Oh my goodness, we are on a roll. Yeah, let's go. Yo.
Shio.
Sham. Are you down to figure out how to do it in linear time and O1 space?
Yes, almost.
What'd you say?
So where are you then the linear time?
Oh yeah, we already doing
see
it.
the domain of one space.
Huh. Is it possible to somehow...
But what if we get just the top? Like we are one, we store the top ones.
Only show the top ones. How do we do that though? Because my worry is, what if you start counting, right? And what if a certain number appears very few times in the beginning, but then it appears a lot at the end? What if we prematurely kick that one out?
Yeah. Well, actually, I think I have an idea. So if we do linear time means we can go through the array multiple times, right? And it's still be linear because if you go through it exactly 3 times, so linear. So what if we go through it the first time and get the most common element, so we avoid that issue that you just mentioned, and then we have the program go through this a second time to get the most common element. And at that point, we can check how often these 2 elements occur. And they would be using linear time.
Oh, I see.
O1 space.
Yeah, it would. How do we figure out, like in one pass, how do we figure out what the most common element is using O1 space?
Well, it's a good question.
It is a good question. Also, someone in chat is saying, LeetCode won't let me import pandas. Devastated. That is pretty sad.
Pandas is all of infinite time. Vanish. Get away.
Well, yeah. How O1 space? I don't understand. You want to look at some, since we're both stumped, you want to look at some solutions? Oh, he says, I was trying to use a series for the first question. Oh, he was talking about the first questions. Oh, okay. Yeah, let's look at maybe this one. Oh my goodness. Answer is, okay. Answer is a empty array control. What is our control? For I and nums, if I is in control. Huh? Control I plus equals 1, else. I think he's doing the same thing we're doing. KV in control items. Wait, he's doing the same thing we're doing. Okay.
Interesting.
Wait, everybody's doing the same thing we're doing.
So I'm wondering if there's some sort of XOR solution, like using bit operations because we say
XOR operation. If length of count... Wait, he's doing something different here. If the length of the count of the dictionary is less than or equal to 2, continue. What is he doing here? Default dict, okay. Less than or equal to 2. New count is equal to default. For every n, comma c and count dicta items. Okay, so if the value is greater than 1, new count n is equal to c minus 1. Count dict is equal to new count. What? Do you understand what he's doing here?
Not at all.
Not at all. Well, it looks like...
Well, just brainstorming here a little bit. But you see, in element, and see in other element, when the two elements cancel out because it's baseline where most elements have one count. So if you know there's only two elements inside an array, you can record how much more you have of one element than another element rather than how many you have of each element. Maybe that was what the previous solution was getting to.
If c is greater than 1, so they're subtracting the count. Huh. For n, comma c. I don't really understand, to be honest. Do you want to move on to the hard problem?
Then let's move on.
Yeah, it's fun. Okay, last question for today. Oh, someone sent me a link. Let me get that. Oh. Oh my goodness, what is this solution? Count is equal to
Is
numpy.
their solution?
He did numpy.
Amazing.
Numpy.unique.
They've got lines of code.
Dang, that's slick. Very cool, Velveteen.
That's
Counts.
code.
That is code, all right. Dang, that is pretty code. All right, thanks for sharing, Velveteen. Okay, maximum score of a good subarray. Okay. Oh, you are given an array of integers nums, 0 indexed, and an integer k. Popcorn reading. Oh, hello?
Yep. The score of a subarray I, comma j is defined as main norms of index I plus norms of index I plus 1, norms index j, and that equals j minus I plus 1.
I
A
have
good
no idea.
subarray is a subarray where I is less than k is less than j.
Return the maximum possible score of a good subarray. I am so confused. What was this line? The score of subarray ij is defined as min. Subarray ij is at like between these two indices. Min of nums I plus 1. Okay, so the min of every single element times j minus I plus 1. Okay, I think that makes sense. So the input example here is this. Integer k. What does k come into play here? A good subarray is a subarray where I is less than k. Okay, so k is between I and j. Okay. Output is 15. The optimal subarray is 1, 5 with a score of 3 times 5. 3 times 5 equals 15. The maximum possible score. Ooh.
Interesting. So it seems like K is kind of like a sort of a pivot where you have in center and you can either decrement I or increment J.
Oh, okay. I think I see it. 0, 1, 2, 0, 1, 2, 3. So that's K. Huh, okay. I guess oh, wait. This could be n squared time if we aren't careful. Oh no. The min times 5 minus 1 plus 3. Because I was thinking we could just start I and j from right next to the k. And then slowly branch out I, branch out j.
Yeah.
And then try out stuff. That's... Ooh. Like for every single I here, for every single k here, try out what the score is. That's n squared time though. Ooh. And then find the max. I would like to look at the hints, please. Try thinking about the prefix before index k and the suffix after index k as two separate arrays. Yep. Use two pointers or binary search. Binary search, we can find the maximum prefix of each array where the numbers are less than or equal to a certain value. Oh my goodness, how do we binary search this? They're not already in order
And what
though.
is that certain value?
Maybe the score? Wait, hold on. The score is the entire thing. Times, is it this thing? J minus I. Ooh. Times j minus I plus 1. Basically the length of the array. Oh. Wait, let me turn on the lights in my room. It's getting dark.
That has fallen.
Apparently we can binary search this. What? The min. Huh. The prefix and the suffix after index k is two separate arrays. Huh. The maximum, huh? Wait. So if k is here, could we try like compute the prefix from like 3 and then 4 and then 1, the minimum?
Yeah.
3, the min 3, 3, 1. Let me copy this example. Oh my goodness. This is the first time we're doing a hard problem stream, by the way. Or like in a guest stream. So no pressure if you don't solve this.
Now we
Okay.
gotta solve this. This is two brains in stream right now. We
0,
have
1,
3
2, 3.
routine here.
Okay, so they're asking us to think about it in prefix and suffix before index k. The prefix and the suffix. could we compute like the min? So the min here will be 3. Min here will be 3
And
still.
maybe what we can do is an iterative algorithm where in the prefix, yeah, like you mentioned, we compute the main. And then we see if we move one up, and if that increases our mean. So it changes our score.
Huh. Wait, are you saying... Wait, sorry, say that again? I don't think I completely got it.
So what we can do is we can compute the score. So what we do is we say I equals 0. We say
Mm-hmm.
compute this prefix score. And then we say I equals 1. Then we compute the prefix score. What we can do is we treat these separate arrays. So what we can do is we can get the mean of the prefix multiplied by the distance from I to K. And they give us our prefix score.
Our prefix score. Oh, like for example, if we start from here, we find the minimum from here, and then multiply by the length, and that's our prefix score.
Yeah, so what we can do is prefix score equals K minus F times the mean of the elements between K and F.
Okay. Wait, how do you combine the prefix and suffix scores though?
Well, we don't need to combine. We can just use it to figure out what the optimal R, comma J is. And then after that, we can just use that and submit it.
Okay. I don't really see where this is going so far, but I think I see the direction you're heading, though nothing concrete.
Yeah, no, I don't have the specifics here, but the idea here is we find the optimal R and then we find the optimal J.
Okay, I'm down for
And we
that.
can do a brute force where we try out all the different possible I's to tell.
Okay. Wait, what if instead of computing the actual score, because it's determined based on the length of the array anyways, why don't we just compute the minimums, since that's what's important here. Min, it's going to increase based on length anyways. What do you think about that? Compute the prefix mins and the suffix mins.
Yeah, it sounds good. I'm not super sure beyond the
I'm not sure either.
in my head. So there is a multiplicative factor to the score. And so the main of the array for the prefix array when you have the I equals 0 is different than the score that you get when the I equals 2.
0, 1, 2.
Even if the mean is the same number.
Yeah, they will be different. Okay, so I think for the prefix mins, we should start from K and then spread all the way out here. So it'll be like 7, 3, 3, 1. Does that make sense?
Sounds good.
Sounds good. Okay. How do we do a for loop like this in Python for I in range K, comma... Oh, I've done this before. So from K to 0, right? And then the step is -1. Is that how you do it? Range, start, end, step. I think that's how you do it.
Thanks, Jen.
Okay. I'm not 100% sure, so I will sanity check the index. Return none for now.
Right.
3, 2, 1. Good. Okay. So prefix score. Oh wait. we should go to -1 because 0 needs to be included. Prefix score I is equal to, we need to compute the min. Min is equal to, is it float dot infinity? Start as the max value. Float infinity.
Thì
Hey, look, Amazon Prime is in our chat. Amazon Prime says, "Are you winning, son?" Do you think we're winning?
yes, Dada, we are win.
We are winning. I mean, I got a really cool guess today. I think I'm winning. Prefix score is equal to the min of. I should name this better. Prefix min. Prefix min is equal to the min of the current prefix min and the current number nums I. Wait, there's a cleaner way of doing this. Prefix min is equal to this. And then the prefix score is equal to the current prefix min. Okay. I'm going to print out our prefix score. Run. Uh-oh. Index out of range. Why? What's our index? No. Print I.
Really interesting. So the goal here is to get everything up to index k. If you want to get a real element up to index k, you had to reverse.
Sorry, I didn't get that. What'd you say?
Maybe you could try to range 0, k and keep the last thing you don't want.
Oh, range 0 to k?
Yeah, where the last one determines the order of traversal. So if you do using digits, if they make it a 1 there. If you 2, then it goes from 0 to 2 to 4. And then if you do a -1, then it does the traversal and reverse tracing.
Oh.
So it should start off with k, t, -1, and so on. So I think if you were trying to know exactly what you're doing before, you can just add another element right there that says -1 as the third argument to range.
Sorry, I don't think I got that. How do you reverse this?
Wait, so what order of traversal are you looking to do? Are you looking to do k, k -1, -2, so on?
Yeah, from k to 0.
Yeah, so this is the third argument in the range function allows 17 to be -1.
-1. So this would print out k through 0?
Không phải.
Huh.
Were they the green out Nelson? Or that's my bad?
Standard out is nothing. Wait. What is k? K is 3. Huh.
Let me try this on my own terminal on my own computer.
My own terminal. K. Wait, I thought we just got this though. K to 0. Run. Let me comment this out. I thought we literally just got it to print like 3, 2, 1. Yeah, here, 3, 2, 1. Yeah. What about to -1?
Say it's in first place.
3210. Well, yeah, we got this.
Well, it's amazing. Seems like both were great solutions. We should keep it then.
Okay.
Yeah, looks amazing.
Prefix min is equal to the min of the current prefix min, comma nums I. Okay. And then prefix score. Oh, I think I know what's wrong. This says length 0 right now, so we're always out of bounds if the index is greater than 0. Times, oh no, what should the length of this be? Length of, what should the length of this be? K through
To make it
0?
boy, okay.
Oh wait, just K, huh? Oh, 0 through K. 0 through K is 1. Hey, we got something. Okay. What's our... Okay. 0, 1, 2, 3. So the min is 7, 3, 3, 1. Okay, we got it. Hey.
Let's go.
Hey. Amazon Prime says Python lists are dynamic. Wait, what does that mean? I don't know what that means. Length?
But I think he's saying you don't actually need to defend the seeds of the array during instantiation. So if you want, if it's to prefix scored on append, and they would work you please well. So
Oh, really? What do I write
line
here?
me if prefix scored on append mean
Oh, the append.
instead of indexing.
Oh, that's so true. Dang.
Okay.
Oh. Yeah, screw this instantiation garbage. Huh. Dynamically sized meaning it will grow as you add. Ah, got you. There we go, 7331. Okay. Okay. And then for the suffix score. Ooh. For I in range, K all the way to the length of nums. Okay, we compute our suffix score. Suffix min is equal to float inf. Okay. What do we do here? Suffix underscore min is equal to the min of the current suffix min and nums I. And then we update our suffix scores. Score is equal to, dot append our suffix min.
It seems like in this case, we're saying that K is part of the suffix mean score.
Should we include it?
I haven't thought about it.
I haven't thought of it. Okay, let's print out our suffix min. Sanity check. Bam. Output is null. 0, 1, 2, 3, 4, 5. It should be printing out like 4, 4. Why is the output? Oh. Suffix score. Why is our suffix min nothing though? Okay. Put this out. Oh, 4, 4. Very nice. Oh. and then print our prefix score. Okay, now the hard part. What do you do from here? We have our prefix score like this, 7331, if we expand like to the left, and then 44 if we expand to the right of K. So we have to maximize the min part, right? If we do 7,
I don't think it means binary search, but I believe we can still linear evaluate. So what we can do is we can calculate the entire score, extra score, independently on the left and right hand. So we have two linear ones.
Like calculate the scores? Wait, you want me to calculate the scores independently on the left and then independently on the right?
Yeah, so maybe we can set the solution the j equals 2k. Even for our prefix score, we evaluate from I equals 0. In the score, the true score when j equals k, and then go through the entire array. It gives us a more accurate prefix score. Then we can do the same thing, and because it's a multiplication, we should be able to do each of these independently.
Oh, wait. Are we actually able to do it independently? Wait, how does that work? Let's say we want to expand 2 to the left, right? 7, 3, 4, and 1 to the right, 4. So the min is 3. Wait. I don't think I'm following. Sorry. What is the plan?
Well, let me rethink this too. But just to define the plan first, the plan that was proposed is that you would compute prefix score again, but in this case, you actually add the multiplicative part to it. But you don't actually know what the value of j is, so you can assume that the value of j is equal to k.
Okay. Yeah, okay. Compute all the scores.
So to get a better, easier representation of prefix score, you do the same thing you did above. Into candidate, but you add in a multiplication part.
I see what you're saying. Okay, so everything in prefix score. So you iterate through prefix score again, multiply everything from the length from k. Yeah? And then the same with suffix. Ooh. I'm not sure. Okay, let's try this. For
Well, actually, I didn't think it mirror. I don't actually know if it can compare these two scores separately. Did you know?
yeah, because I'm not sure about that either, because computing, we have to multiply the length. Can we do that after the fact? Like, hmm. You know, something I noticed is that the minimum always gets smaller as you get away from k, right? Is there a greedy solution to this? What if we start at the ends, right? And then which one is smaller? We move inwards. Because
That, and you can see if the additional one that you take is actually worth it. So it seems like The even the even work. It could be
With this,
worth it to take the Shock 3 because it additional plus one on the multiplicative factor. So that makes up for it.
I think your voice might be like a bit distorted.
Pardon me.
Sorry, what were you saying? I was saying that maybe we can do a greedy solution, like put a pointer here on the leftmost, put a pointer on the rightmost, and then slowly move in. Whichever one is smaller, you get rid of it. So 3,
Yeah, this sounds like a good plan.
4, yeah, like a greedy, and then we keep seeing which one is the biggest. Wait, okay, I think I want to try that. Yeah.
Terrains.
I is equal to 0, j is equal to wait, yeah, that's kind of like, actually, yeah, I don't know what I'm talking about. J is equal to length nums minus I. Okay, so while I is less than or equal to k, less than or equal to j. You can do this in Python, right? I think so. Okay, and we keep moving in the smallest one. If nums I, well, if the prefix score I, if the prefix, what do we call it? Prefix score? Prefix score I is less than suffix score j, then you move I inwards because I is the one killing the minimum right now. So I plus equals 1. Else, I can, my keyboard, j minus equals 1. Okay, and then you keep computing the best score. Best score is equal to, let's instantiate this to float, negative infinity, sure. Okay, and then the current score is equal to the min of the prefix score I, comma, suffix score j. Whoa. Times the length between ij times j minus I plus 1. Okay. Times j minus I plus 1. Okay. Does that make sense so far? I think it makes sense. It's equal to
Be assumed that our plan.
best score. So the best score is equal to the max of the current best score and the current score. Whichever one is bigger. And then you move in your i's and j's accordingly. And then you return your best score at the end. I'm so paranoid. I have a feeling this won't work. Index out of range.
Well, why
Score.
don't we try it?
Yeah, we'll try it. Suffix score j. Oh, wait. There is no j. Oh, wait. It's not a direct mapping of so, oh wait. Uh-oh, this is gonna get confusing. The prefix score is the distance from, oh, my brain, it hurts. So this is actually k over here. This is k minus 1. Oh, no. This is k minus 2. How do we convert it?
Oh,
We probably have to do, wait, so if I is 0, this would be here. So we would probably do, oh my goodness, the length.
well, we can do some like, yeah, the length. With minus.
The length minus length of prefix underscore minus I. Ow, this hurts my brain.
Why don't we see in a detail yet? So if I equals 0.
We start from here.
Wait, no, I think it should start from this I, right? And then the suffix should be length of suffix minus I.
Suffix score. Wait, but the min is going from 7341. 7341. 7331.
Yeah, so in your prefix computation, you just averted it.
Oh, you want me to revert it in my prefix?
Well, no, I'm suggesting line 33. The prefix score should be the index I, and the suffix score should be the length of the suffix score minus J. Does that make sense though?
4. Suffix score. So suffix will start at J, which is the last thing. 0, 1, 2, 3, 4, 5. Oh, wait.
Let me clarify here. So starting from the center, clear, and spinning outward to left and right.
Yeah, so this is 4, 5. This maps to 4, 5, the min. That's the suffix, that's the prefix. So, you know what? Should we? Should we compute the? Should we compute the minimums, like these scores in one array instead, so we can just map the indices directly? The indices will be the same.
It's kind of seems like a plan.
Seems like a plan. Okay. Whoops, sorry. Okay, I will change
Why don't
these.
we revisit the hints?
Okay, the hints. Try thinking about the prefix before index k and the suffix after index k as two separate arrays. 2 pointers, we can find the maximum prefix of each array where the numbers are less than or equal to a certain value. I think we're on the right track. Okay, I think I want to, since it's getting too confusing down here, I want to compute the relative minimums all in one array, so that we can use the exact same indices down here. Yeah?
Well, if you want, you can just combine these two arrays and then see and check you're combining it correctly.
We can just combine it.
Yeah, so in line 23, we should have something like command array equals, and you just have the two arrays.
Oh, that's
And then
true.
they'd be automatically command to one array.
Hmm.
To Amazon's point, Python has the dynamic arrays.
Oh, is this how you add arrays? Python add arrays? We need to reverse this one too. Seven, three, three. Okay. Python, how to add two arrays. How to concatenate two arrays. Plus operator, okay. How do you reverse? How to reverse array. Reverse to my list. Or we can just do this. Okay, okay. Okay. Scores is equal to this. Let's print out the scores. Yeah, sorry, this is a little confusing. Scores. Scores. So these will just be I. Scores J. Okay, I'm more curious about the scores if it's computing correctly. Oh no. Okay. So 7331, 744. Okay, that looks right. Nice. If the prefix score, oh, here. So if the min on the right is the one weighing the scores down, then I plus 1. Okay. Nice. Belle, we did it! Yo,
Let's go!
let's go. We saw. Wait,
Zero!
let's not count our chickens too fast. Please, work. Work. Oh! Oh!
Amazing.
Amazing. Wait. Let's delete all of our extraneous stuff. Let's delete our prints. Yo, we figured out a greedy solution together, man. Wow, Pam. Submit. Top 22. Okay. Oh, wow. Good enough. I didn't think we would be solving this anyways. It's good enough. Yay. Oh, that was nice.
Congratulations, Sid.
Congratulations. Thanks for helping me too. You helped me arrive on the greedy
We
solution.
did it.
We did it. Oh, Velveteen is cheering in the chat. Uh-huh. Oh,
Thank you very much.
that was nice. Okay. Do you have anything you want to shout out or plug at the end of the stream before we go?
It's plugging Valentina Amy and Balloon Prime. Thank you for your support. Please like
Yeah.
and subscribe to Sid.
Thank you. Oh, I think some of my viewers are wondering this too. Do you have any advice for people who want to like advance their careers and get into a cool company like Google too?
And I understand the tech environment is pretty tough right now. I think the first step is getting an interview. So you can work on that. You work on studying for your interviews after.
So you're saying prioritize getting an interview and then study for the interviews after.
And also watch more chat.
Watch more
That's
chats.
how you can prepare for your interviews.
Wow, thank you for the shout out. Sure, maybe watching me can help you get a little better. All right, thank you. I still can't believe we got this last one correct. I think this is the first hard problem we've solved on a collab stream. Okay. Thank you so much, Belle, for coming in this stream. I really appreciate it.
Likewise, thanks for having me, Chet.
Yeah. All right. Thank you, everyone, for coming. I appreciate it. See y'all next time. You have anything you want to plug or say before we drop?
Be yours. Thank you, everybody.
Bye, Velveteen. Thanks for coming. Alright, I'm ending the stream. See ya.